Hello students, good morning. I hope you all are safe and healthy at your home. In our paper 506, in last two lecture, we started unit 2 and in first lecture we classify drugs and in second lecture we studied about anti-tuberculosis drugs. Now, in this lecture, we studied about anti-leprosy drugs. In this lecture, we first of all show introduction. Then after, we have three anti-leprosy drugs. So, we will synthesize them and their medicinal application. We first of all start with anti-leprosy drugs. Introduction. Leprosy is a slow endemic disease which is caused by Mycobacterium leprae. Mycobacterium leprae, please note this name. It is the bacteria which is caused the leprosy. Mycobacterium leprae. The development of an infection takes many years to become apparent, and the progress of medication has been found to be equally slow. The search for antileprotic drugs has been hampered by the inability to cultivate Mycobacterium leprae on artificial media and by the lack of experimental animals susceptible to human leprosy. Now, a method of isolating and growing Mycobacterium leprae in the food pads of mink has been reported and may allow for screening of possible anti-leprotic agents. Various anti-leprotic drugs which are used in the treatment of leprosy. So we list out all the drugs which are used in leprosy as a anti-leprotic drugs. Number 1, hydrocarpates. Number 2, dapsone. Number 3, solapsone. Here is spelling mistake. SOLAP. P is not in spelling. So number 3 is solapsone. 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 Sodium glucosulfone. Number 5, sodium sulfoxone. Number 6, promizole. And number 7, acid option. According to our syllabus, we have only 3 anti-leprotic drugs: dapsone, solapsone, and acid option. So we synthesize these 3, dapsone, solapsone, and acid option, in this lecture. We start synthesis of dapsone. Dapsone is also known as DDS. It is the short form of dapsone. Dapsone is synthesized from 1-chloro-4-nitrobenzene. 1-chloro-4-nitrobenzene. It is also known as para-chloronitrobenzene. Para-chloronitrobenzene. If we start numbering from here, ortho, meta, and para. So it is also para-chloronitrobenzene. 2 moles of para-chloronitrobenzene is treated with sodium sulfide Na2S Interaction between these 2 mole of parachloronitrobenzene or 1-chloro-4-nitrobenzene and sodium sulfide removes 2 moles of sodium chloride and give product of di 4-nitrophenyl sulfide. In this reaction, chlorine from here and second chlorine from here and 2 atoms of sodium from sodium sulfide are removed and we get di 4-nitrophenyl sulfide. After this is treated with chromic acid. Here is oxidation unit process takes place in presence of chromic acid C2 sorry H2CrO4. This is the chromic acid. So in presence of chromic acid, oxidation process takes place and we get di 4-nitrophenyl sulfone. It is noted that in second step there is sulfide only S, but we proceed oxidation, then it is converted into SO2 and it is sulfone. So in this step we get yield di 4-nitrophenyl sulfone. Then this di 4-nitrophenyl sulfone undertake by reduction unit process. In this reaction, we see there is NO2 group. So this NO2 is converted into NH2. NH2. And our final product 4,4-diamino diphenyl sulfone. It is known as Depson, or we in starting we derive it by DDS. It is derived from its chemical name 4,4-diamino diphenyl sulfone. D from diamino, second D from diphenyl and S from sulfone. So it is also known as DDS, diamino diphenyl sulfone. Now, industrial or medicinal application of Depson. Depson is used in the treatment of both lepromatous and tuberculoid types of leprosy. It is also used in tuberculoid type leprosy. Please note this. Second, it occurs as an odorless white crystalline powder. It is the property of Depson. Odorless and white crystalline powder. Number 3. It susceptible to discoloration in light. It is also important properties of Depson. It is susceptible to discoloration in light. And last, number 4, although no chemical change is detectable following discoloration, the drug should be protected from light, so it is kept in dark. These are the medicinal application and some properties of Depson. Our second compound in antileprotic drug is solapsone, and solapsone is synthesized from Depson or DDS. This Depson is treated with 2 moles of cinemaldehyde. I state here structure of cinemaldehyde. 2 moles of cinemaldehyde and depson are treated. Here condensation unit process is takes place. After condensation, we get derivatives of Depson. We see the reaction hydrogen to atom of hydrogen from Depson here and oxygen from cinemaldehyde. It is from here and it is from here. So minus 2H2O. Two water molecules are removed and we get derivatives of depson. In this structure, here is some mistake. Here not CCH4 but here is CH bond CH. CH bond CH. Both sides of these derivatives are same. So here is 6 5 C6H5 CH double bond CH bond CH bond double bond N. So here is also that type of structure, N double bond CH bond CH double bond CH bond C6H5. After this, we treated this derivative of depson is with sodium bisulfide. 4 moles of NaHSO3 sodium bisulfide. After reaction, we get our final product solapsone. We synthesize solapsone from cinemaldehyde and depson by this route. Now, medicinal application of solapsone. It is an almost white powder unlike depson. It is also its property. It is very soluble in water. It is more slowly absorbed than depson. So solapsone is very important. And last, solapsone is largely inactive and owes its activity to metabolism to semi-solapsone, the monosubstituted derivative of depson. This is the medicinal application and synthesis of second compound solapsone. Now, our in this group, last compound is acidopsone and its short name DADDS. DDS is from depson and here it is also diacetyl derivative of depson. So acidopsone is also known as DADDS and its chemical name is NN diacetyl diamino diphenyl sulfone. We also synthesize acidopsone from depson, but in this lecture and in this synthesis we use other route and we synthesize it from parachloronitrobenzene. 2 moles of parachloronitrobenzene is treated with sodium sulfide as we describe this reaction in depson. So we in this reaction 2 moles of sodium chloride is removed and we get di-4-nitrophenyl sulfide. After this, we treated reduction, acid metal reduction in presence of tin and hydrochloric acid. Reduction unit process takes place. So, di-4-nitrophenyl sulfides nitro group, these are the nitro, both NO2, here is NO2, is converted into NH2. After reduction we get para-dash diamino diphenyl sulfide. It is the metal acid reduction of di-4-nitrophenyl sulfide. In next step, we treated para-dash diamino diphenyl sulfide with acetic anhydride. Acetylation process takes place. In presence of acetic anhydride, para-dash diamino diphenyl sulfides, both NH2 group, is converted into NHCOCH3, NHCOCH3, and we get para-dash diacetyl diamino diphenyl sulfide. After this, it is treated with potassium permanganate KMnO4. Oxidation process takes place. So, only sulfur sulfide is converted into sulfone. It is described here. Here S is converted into SO2. So, in presence of KMnO4, sulfur is or sulfide is converted into sulfone, and finally we get NN diacetyl diamino diphenyl sulfone. It is our final product, acidaption, and short name DADDS, D from di, A from acetyl, second D from diamino, third D is diphenyls, and S from sulfur. So it is also known as DADDS. This is the synthesis of acidaption. And now medicinal application of acidaption. Acidaption is used in the treatment of both lepromatous and tuberculoid type of leprosy. Second, it is longer active and has low toxicity as compared to that of dapsone. So it is better in leprosy. It is less toxic. Is it not that? It is less toxic. So it is used instead of dapsone. Number 3, it is longer active and has low toxicity as compared to that of dapsone. Number 4, in the treatment of both tuberculosis and leprosy, one thing to be remembered is that the treatment with the drugs has to be continued for a long period. We say in anti-tuberculosis drugs, it is long time process, 3 to 6 months. So, and though the frequency of administering the drug is decreased gradually, but the doses are increased. And last point, chemically, we also state its name as chemically. Chemically, it is NN diacetyl diamino diphenyl sulfone. That is, it is acetylated depson. So we get it from depson also. In starting of this synthesis, I say we also synthesize acidapson from depson. Thank you.